In this video, we're going to learn how to use a quadratic equation in a real-world scenario. So when serving in tennis, a player tosses the ball vertically into the air, and the height h of the ball in seconds is given by this quadratic equation, -5t squared plus 7t. So the height is measured in meters from the point of the toss. So the moment it leaves the hand, it measures how high above the hand it is as it goes up and then back down. So first wants to find out how high in the air does the ball go. Now, its highest point on a parabola, especially here with a being negative, it means we have a downwards parabola. The highest point is at the vertex. So when I see this equation, h of t is equal to -5t squared plus 7t, I can tell that a is equal to -5, b is equal to 7, and c would be equal to 0. But since I don't need c for this, usually to find a vertex, I need to find out what h and k are for it from standard form. And h is the formula x equal to negative b over 2a. So I'll just plug into that formula. So h is equal to negative of 7 over 2 times -5, which simplifies to the negative will cancel, or I will have -7 over -10, and then the negatives cancel, 7/10. So I know the x value is 7/10. So after 7/10 of a second, I'm at the highest point in the toss. But how high up how high up in the air does the ball go from the hand? Well, to figure that out, I need to take this number and plug it back in to find the y value, which will tell me the height. So I'm looking for h of 7/10, which would be -5 times 7/10 squared plus 7 times 7/10. So that would be -5 times 49/100ths plus 49/10ths, which will give me -5 times 49, which is -245 over 100, plus I need a common denominator, so 490 over 100 by multiplying the top and bottom by 10. Adding those together, I get 245 over 100, which can be simplified. Both the top and the bottom are divisible by 5, so 245 divided by 5 gives me 49 over 20, it seems, which is also equal to 2.45. Now, that was some tough math there, but I actually want to show you a feature in the calculator that can make sometimes inputting values a little bit easier. If I were to input this expression into y equals, now I need to put it as x instead of t, but that's okay. So -5x squared plus 7x. If I do second mode, I can bring up that y1 variable by hitting vars, which stands for variables. Going to the right where it says y variables, enter on function, hit enter again, and now it brings up y1, which is kind of the same as h of. If I put in 7/10 into the parentheses, it'll spit out 2.45, which is that number I was looking for, and maybe could have saved some time for us. Now, so our answer would be 2.45 meters in the air, or 49/20 meters. Now, let's assume that the player hits the ball on its way down when it is 0.6 meters above the point of the toss. So it gets up as high as 2.45 meters, but not 0.6 on the way up, but 0.6 on the way down. So after 7/10 of a second, he's going to hit the ball. The way we figure this out is we know that h of t is equal to negative 5t squared plus 7t, and we know the height needs to be 0.6. Now this could be a difficult equation to solve. If I were to move everything, I'll move it all to the left. I can get 5t squared minus 7t plus 0.6 is equal to 0, which if I change 0.6 to a fraction, that's 3/5. So I can get 5t squared minus 7t plus 3/5. And by multiplying each side of my equation by 5, I can get rid of that fraction, give me 25t squared minus 35t plus 3. And now I'm trying to see if I can factor this expression. So already this is looking pretty difficult to accomplish. First of all, I need to find two numbers that would multiply to 75, but then add to negative 35, which may or may not be possible. So what I'm going to do instead is show you another trick that you can use on the calculator to see if you can figure out the height, and it actually involves this expression here. I already showed you how to do it when it's equal to 0, but let me show you what it looks like if I were to do it from this point right here. If I go to y equals, I'll keep my expression in y1, but in y2 I'm going to put what it's equal to, 0.6. If I go to graph, it'll graph my parabola and a line at 0.6. I'm going to make my window smaller so you can see that better. So I'm going to go from negative 4 to 4, and from negative 4 to 4 in my y. But you'll see here, here's the parabola, and this is that line 0.6. So you'll see the tennis player tosses up in the air. It hits 0.6 for a little bit. It goes up to its highest point and then back down. And I want to know where that point is, where those two lines intersect. If I hit second trace, I can go to intersect, which is the fifth option. And on the first curve, the parabola, I'm going to move it near that intersection point that I want to figure out, the second one, which is on the way down. Hit enter again, and I can guess at what the intersection point is, and it's that x is equal to 1.308, which I will round to the nearest hundredth, 2 decimal places. Or I'll keep it at 3, 1.308 seconds. So at that much time after it leaves their hand, they will hit the ball with their rackets. And that is how you use a quadratic equation in a real-world scenario.